here and in terms of symbols, so we can ignore. So we can another start it. Good, good. And now we have done the typical Laplace transform, and I'm going to go to inverse. So a new one. So this is inverse Laplace transform. So that means in these sections we're going to spend quite a bit of time today and Monday and to deal with this one and how to find the inverse Laplace transform of this. Okay, and the same thing we see. And we're going to exercise the same. So we're starting from here. Now it's time for me to pick up my notes in case I make a mistake. Okay, so for this example, how to do it, and the principle is this. We decompose this composite function into the combination of the simple one. Okay, I think you have this kind of the exercise before in certain classes, but let's do it again. So for this one here, let me write it up here again. 5s plus 3, and s plus 1, s plus 2, and s plus 3. For this one, we want to decompose into the simple combinations, the combination of the simple terms. And the simple term, that means using the denominator as the crude, basically that's the multiplication of the three terms. So here we're going to decompose is using the denominators. Sorry. So here we simply going to look for the numbers in the numerators here. Okay. So how to determine the ABC? I think the better arrangement is into this, because that one can allow us to see this clearly. Okay, determine ABC, and let me write it up. Let me give the thinking first, and then I'm going to write it up the equations. For A, how to calculate A? You can see if we both sides to determine the value of A, and what we do is this: we simply multiply s plus 1 on the both sides of these equations. So let me kind of mess up here. So if I'm going to multiply s1, so basically on the both sides, this one will be gone, this one will be gone, and this one multiply s plus 1. Let me write it up here. This one s plus 1. Let me write it up here. Okay. And then in this way, then the second step is to, you can see from here, we only want to determine A. So likely in this equation, if we set s equal to minus 1, then this term is gone. This term multiplied 0 is gone. Okay? And then this term we simply calculate. That one will be equal to 5 times minus 1 plus 3, minus 2. And minus 1, so that is 1 times 2 equal to A. We do these things on the both sides. Okay? I simply introduce, let s equal to minus 1 into this equation, do the calculation on the both sides. So in this way, A equal to this number, A equal to how much? Minus 1, right? Okay, so in this way, we combine the things together. We can have they call the formula, but I don't like formula because if you have a more formula, you need to memorize, and likely you can make mistake. So basically that's the thinking process, but you can merge the two things by doing this. Is this, and let me define these functions is f of s. So that means f of s, original function on the right hand side, multiply with s plus 1, and then we have the s value equal to minus 1, and this is our a. Okay, good. And how do we know this is minus 1? Minus 1 is coming from the denominators of this term s plus 1, so we set up s equal to minus 1. In a similar way, you can keep practice for b by repeating the two steps on the single scratch papers. Okay, but quickly, b can be equal to, again, this is the left-hand side of these functions, and right now for b, we going to multiply with s plus 2, and then we set as value equal to minus 2. Be good? Okay, this is simply the very concise writing of the two steps, but I don't think that will spend too much time if you simply write it out. I think that would be the better way. Okay. So in this way, repeating the whole thing, then in this way, a will be equal to minus 1 s plus 1 and plus 7 s plus 2 plus minus 6 s plus 3. Good. So right now we want to do the inverse of the f of s. Again, right now we simply apply, that means the inverse f of s equal to the three terms. So the inverse will be individual of each, will be the inverse of the Laplace transform of the individual terms. Okay? Good? Okay, now for individual terms, right now we want to do the inverse of the Laplace transform. And here is the formula here. Right now we have 1 over s minus a is inverse corresponding, this is ft, this is our f of s. So this is the time domain, the function of t. This is a function of s. This is the Laplace transform term, and this is the inverse Laplace transform term. So we're using this formula here. So right now you can see for this case, we do this carefully. So right now, basically this one we're using, let me do this further, one more step, and s plus 1. And this one, let me take the coefficient out of the s plus 2 and minus 6 Laplace s plus 3. Okay, so right now I simply take the coefficient out because you remember the linear combination in the S domain equivalent is linear combination in the time domain. I use that properties. Okay, so that one, okay, now we can begin to look at this term. This one corresponding to this formula a equal to minus 1. So that means its inverse of Laplace transform is minus p plus 7. For this one, a equal to minus 2. So that is e minus 2t. And for this, a corresponding to this formula is minus 3. So that is e minus 3t. Good. So that is our answers. Okay. We'll look at another example here.